The last topic that we'll cover about logarithms is graphs of logarithms. Okay, so our goal is to graph logarithmic functions, and then we are going to learn to determine the domain and vertical asymptote of a logarithmic function. Okay, so if we have f of x is equal to log base a of x, remember that a has to be greater than 0 and different than 1. So it can't be negative, it can't be 0, and it can't be 1. And x has to be greater than 0. What we have is what's called a vertical asymptote at x equals 0. So I have the graph drawn here. There is a point at 1, 0, and that's because if x is 1, we have log base a of 1. And let's say we want to know what that is equal to. That means that a to the y is equal to 1, which gives us y is 0. So that's how we get 1, 0 here. Okay, and then it continues to kind of slowly make its way up. Now the vertical asymptote at 0, and let me zoom in a little bit, is it looks like it here, but this will actually never cross 0. So sometimes you'll see an asymptote with a dotted line. Okay, note that since x has to be greater than 0, we can never hit 0 and we can never go past it. So kind of what I think of with what's called this vertical asymptote is if you've seen Lord of the Rings, there's a scene with Gandalf and he's saying, "You shall not pass." Okay, that's the vertical asymptote. This graph shall never pass that line or go to the left of that line. Okay. So example 1, so f of x is equal to log base 5 of x. So when we're graphing these, there's usually only a couple of values that I plug in. I plug in x is equal to 1 because of what we just saw, that y would be 0 in a case like this. And then I plug in whatever the base is. So in this case, the base is 5. So if we look at this, remember that this means that 5 to the y is equal to x. Okay. So we would have 5 to the y is equal to 1, which gives us y is 0. And if we have 5 to the y is equal to 5, this gives us that y is 1. So there's a point at 1, 0, and there's a point at 5, 1. And our vertical asymptote would be 0 because this has to be greater than 0. Okay, so we have 1, 0, 5, 1. And it'll actually look something like this, where it's never going to cross over, it shall not pass over the vertical line, x equals 0. Okay, and here's what it looks like. Okay. So state the domain and the vertical asymptote of f of x equals log base 5 of x. So to get the domain, you take whatever's inside the log and set it greater than 0. Okay, so whether it's x or some other expression, which we'll see, we set it greater than 0 and we write our domain in interval notation. So anything greater than 0 would look like 0 with a parenthesis because it can't be equal to 0 to infinity. Okay, the vertical asymptote we can take whatever's on the inside again. So in this case, x equal to 0. So this is our vertical asymptote. Okay. So let's look at something if we have a shift. So we have f of x is equal to log base 5 of x minus 4. So this starts with the base graph of log base 5 of x, which we just did. So there's a point at 1, 0 and 5, 1 that looked like this. Okay. And so now this minus 4 is a horizontal shift, right 4 units. Okay, so everything moves to the right 4 units. So we go 1, 2, 3, 4, 1, 2, 3, 4. Okay, and even our vertical asymptote moves over 4. So our asymptote was at x equals 0. It's now going to be at 4. Okay, so here's our asymptote, the line that's never going to cross. And here's what the graph looks like in blue. Okay. So state the domain. So for domain, we set what's inside to be greater than 0, and then we solve. So we add 4 to both sides, so this gives us x greater than 4. In an interval notation, that's 4 to infinity. And then for our asymptote, our vertical asymptote, I should mention it's a vertical asymptote because it's a vertical line. There are such things as horizontal asymptotes too, that graphs don't go below horizontally, but in this case we have vertical, that it's never going to pass. Okay. So we have vertical. And to find that, we take x minus 4 equals 0. And so we have x equals 4, okay, if we solve that for x. Okay. So graph f of x is equal to log base 7 of x plus 2. So in order to graph this, this is a shift as well because we've got x and we've got a number being added to x. So we would start with the graph of f of x is equal to log base 7 of x. And remember, I always plug in x is 1, which will give me y is 0, and I always plug in x as the base, which gives me y is 1. Okay, so I have a point at 1, 0, and I have a point at 7, 1. 7, 1, oops. And my vertical asymptote, so it gets really, really close to x is 0 as the graph goes down, but it never crosses it and it never touches it. Okay, so this is what my graph of log base 7 of x looks like. This plus 2 means that we go to the left 2 units. Okay, so everything goes to the left 2 units, including that asymptote, so it's going to go 1, 2. Okay, the point 1, 0 goes over 1, 2, and the point 7, 1 goes over 2. So our graph looks something like this. Okay. So state the domain. So for domain, we take x plus 2 and set it greater than 0. By solving for x, we get x greater than negative 2. So if you draw this out to right interval notation, you would get negative 2, parenthesis, because it cannot equal negative 2, to infinity. And then for the vertical asymptote, we take what's inside x plus 2 and set it equal to 0, and we get negative 2. Okay, so x equals negative 2 is the equation of our vertical asymptote. Okay, there's one more thing about logs that can help us with graphing. So remember that if we have y equals log base a of x, we can convert that into an exponent, x equals a to the power of y. So if you were asked to graph something like this, x equals 4/3 to the power of y, this is different than our exponential graphs. When we were doing our exponential graphs, we would have something like this. Okay, and it does make a difference where x is and where y is. So something like this would be harder to graph, but what we can do is we can convert it to a log and then graph that instead, okay? So remember, if we have x equals a to the y, this means that we have y equals log base a of x. So our base of the log is 4/3. What's inside the log is x, and this is equal to y. And now we have a function that we've just talked about graphing, to where we can plug in x is equal to 1, which gives us y is 0. And if we plug in x is equal to 4/3, we get y is 1. Okay, so we have 1, 0, and 4/3 is a little over 1, maybe something like this, with our vertical asymptote still at x equals 0. Okay, thank you for watching. If you have any questions, feel free to reach out to me.